Hello and good evening, CSI 258, Section 847 students for the second 8-week term of the 2015 spring semester at Anne Arundel Community College. This is our final packet tracer activity. This is it, the culmination of a year of study, and it comes down to packet tracer activity 9.3.1.2, where we are actually going to pull together literally just about everything that we have studied to this point, and it all is incorporated into this packet tracer activity. So let's take a look here at the scenario. XYZ Corporation uses a combination of frame relay, PPP for WAN connections. Other technologies include NAT, DHCP, static and default routing, EIGRP for IPv4, inter VLAN routing and VLAN configurations, security configs including SSH, port security, switch security, and ACLs. So it looks as if there's 99 points here, and it looks like there may be 99 configuration tasks that are going to be required. So let's go ahead and let's jump in here, and we'll start out with the SSH configuration on the HQ router. So we'll slide this down here, give us a little more room to work with. Alright, so we're on the HQ router. We're going to go from user exec to privilege exec, and the password is class. And it says we're going to set up SSH for remote access. So set the modulus to 2048, and the domain name is ccnaskills.com. And interestingly enough, we'll go to global config here. They put these in, there's an order of operations concern here that we need to be aware of, and that is if I try to say crypto key generate RSA, you can see it's going to tell me we've got to put the domain name in there first. So let's go ahead and work that in. So IP domain name is going to be ccnaskills.com. So we get that added in, and we should get, there it is, we get a point for that. So now we'll run back to this crypto key generate RSA. It says the key should be 2048 bits with a modulus of 2048 bits. So we should work, it doesn't give us a point for that, but that's okay. We'll keep driving on here. So we need to configure a username. So we'll say username admin, whoops, username admin, password is admin only. Now it says only allow, or only SSH should be allowed on the VTY line. So we'll say line VTY 0 to 15, and we'll say transport input SSH. Now it's possible, we got a point for that. Let's do transport output SSH as well, so that if SSH connections are originating from this router, that it's only going to allow outbound SSH. And then finally, we'll add in our login local for the username that we created above. So now we need to modify the SSH default. So remember, that's the IPSSH command. Whoops. So we've got the version, timeout, and authentication retries. So we're going to set it to version 2, 60-second timeout, and 2 retries. So IPSSH version 2, IPSSH authentication retries 2, and IPSSH, what was the timeout? Timeout 60. Alright, so we get all of those added in there, and so that should wrap up the entire configuration there for the SSH piece on the HQ router. So now what we're going to do is we're going to configure frame relay between the HQ router and B1. So these two routers right here, it says refer to the addressing table for the IP address, subnet mask, and the DELC. So HQ uses a point-to-point configuration, subinterface, and DELC 41 to connect to B1. The LMI type must be manually configured as Q933A for both headquarters and B1. So we're definitely going to have to come take a look back here at the addressing table, and we're going to be using subinterface 41, and it's going to be DELC 41 here on the HQ router. So let's do a do show run, and let's see what that subinterface currently looks like here, or if it's even on here yet. So we've got gig 00, there's the serial 000, and it is shut down. No sub interface yet. All right, so let's go ahead. We're in global config. Let's set up our sub interface. So we're going to say interface serial 000.41. Now if I hit enter here, we should receive an error message telling us there, and there it is. And this, you might remember this from the frame relay chapter, is that we cannot create the sub interface. We actually need to go ahead and put in here what kind of a sub interface is it going to be. If I were to do the question mark, you can see we can do a multi-point or point-to-point, right? So we're going to go ahead and say point-to-point because it's indicated that we're going to be doing a point-to-point sub interface down in the instruction area. So let's see, it says unable to create frame relay sub interface. Am I missing something here? Am I on the right interface? Yeah, we're on the right interface. I should not have to bring this up. Let me see if that was it. Unable to create frame relay sub interface. We should be able to. Oh, sorry about that. Yeah, so totally forgot. None of the settings are actually on serial 000 yet. So let's go back into serial 00. Sorry about that. And we want to add in the encapsulation frame relay, and we're going to also add in the frame relay LMI type, and that needs to be the Q933. Okay, there we go. For some reason I thought I saw that configured already. So now it's up. Now we go to do the sub interface. Now the sub interface, we're able to configure the sub interface on the router. So we've got our sub interface in there. Let's throw our IP address on our sub interface. So the IP address is going to be 10.255.255.255.1 and 255.1 and sorry about that, 252. So we'll get the right subnet in there. So we'll add the IP address in, and then we're going to say frame relay, and if you do a question mark, what's our delc going to be? The interface delc. Remember the first 16 or the first 15 are reserved, so we start at 16, and our delc is 41. So we'll drop the delc in there, and on the HQ side, that should be it on the HQ side. All right, now we also on B1 need to do the configuration for the frame relay on its serial interface. So let's jump over here to B1. And remember, the point-to-point sub interfaces are in the same, just like a point-to-point circuit, right? So class is the power. Is it Cisco? All right, Cisco, and then we'll go to privilege exec, and the password is class. All right, so let's do a show run here. Let's see what we've got. So there's the interface, right? You can see the serial 000 interface on router B1, and we need to add in our encap. So let's go to global config. We're going to say interface serial 000, and we need to tell it what kind of encapsulation is it going to use, frame relay, HDLC, or PPP. So in this case, we're going to be using frame relay, right? Because the other side of this link is frame relay on HQ. And then again, the frame relay LMI type is going to be the Q933A. So I'll add that in here. Let's see, can I ping across to 10.255.255.1? All right, fantastic. So we've got connectivity from B1's serial 000 interface through the frame relay cloud up here to the point-to-point interface we configured on HQ. And let me go ahead and see do ping 10.255.255.2, and that is definitely not going to work. How about that? Okay, great. So we've got connectivity. That should do it for the frame relay. Let's take one last look here. Got the subnet mask. Okay, great. All right, so let's slide down, and as you can see, we've got a pretty long list of tasks here. So PPP, configure the WAN link from HQ to the internet using PPP encapsulation and CHAP authentication. So I'm going to pull HQ back up here. Let's say do show IP interface brief. I want to determine which interface is my internet facing interface. As you can see here, serial 010. So if I say interface serial 010, we're going to say incap PPP, PPP authentication CHAP, whoops, PPP authentication CHAP, and now let's look. We're going to need a username and a password. So I'll say username ISP, password Cisco, and there we go. So our link to the internet is now up. So let's see here. Do we have the IP addresses for those out there? So they don't give us the IP addresses for these outside hosts. So if I pull this host up here, let's take a look. So 209.65. So let me copy this. And let's see. Do I have connectivity from the HQ router out to that host? Can I get out there yet? It doesn't look like it, right? So we may still have some work to do. So let's go ahead and take a look here. So configure the WAN link from HQ to new B, which is up here in the upper right hand corner. Configure the WAN link from HQ to new B using PPP encapsulation and PAP authentication. So let's determine here what interface. Do show IP interface brief. And we know that that's our frame relay interface. We know that that goes out to the HQS1. This is to the internet. So our interface with new B should be this guy right here. So serial 001. So let's go ahead and say interface serial 001. I'm going to say incap PPP, PPP authentication PAP, and now we're going to send, let me do a do show run, let's make sure it's not on there. So the serial 001, alright, so there's our setup with incap PPP, PPP authentication PAP, and we are the DCE side, so I'll leave the clock rate as what it's set to. It says you choose the clock rate, but we'll leave it the way it is because it's already set to 2 megabits a second. So create a new user, new B with the password of Cisco, but we need to remember to send. So PPP PAP sent username, we're going to send HQ as our username with a password of Cisco because we need to send our information across to the new B router. Let's exit out here and let's do another username, and it's going to be new B, the password of Cisco. So we now have the PAP authentication configured between, and there we go. All right, fantastic, and the line has come up. Okay, and that is the PPP config. That's it. All right, now to the NAT configuration, and this is typically the NAT piece of things is typically the most difficult for new learners. Let's go ahead and dig in here. So it says configure static and dynamic NAT on HQ. So allow all addresses for the 10.0.0.0/8 address space to be translated using a standard access list named NAT. So remember, I can't simply type in here access list 1. There's no way for me to give it a name, right? So remember, in order to do the named, and this is for standard and extended, we have to start out with IP access list, and then I'm going to say standard, and the name of the list is going to be NAT. And so what am I permitting? So it says allow all addresses for the 10.0.0/8. So permit 10.0.0.0, and /8 has a wildcard mask of 0.0.0.255. So that's my access list. Okay, let me make sure here. So it says XYZ Corporation owns the 209.165.200.240/29 address space. So the pool HQ uses addresses .241 to .245 with a 29 mask. All right, so let's go ahead and define our IPNAT. Oops, our IPNAT. Oops, sorry about that. I need to get out of the ACL config. So IPNAT pool, And what's our pool name going to be? It's going to be HQ. And what's my starting address? Well, it's going to be 209.165.200. Now I could put 240 and then put my close it out with the ending IP with the broadcast address. But I'm going to go ahead and stick with the two addresses that they've provided here, 241 and then 209.165.200.245. Is that correct? And then what's my net mask? So a /29 is 255, because remember /30 is going to be 252. So right below that is going to be 248 for the /29. Let's see if we move the point meter at all here. And oops, I apologize. I got a small typo in here. And 45. There we go. All right. Do we move the meter at all? We did. Okay, good. All right. So we've created the access list. We've created the NAT pool. So now let's go ahead and associate. So IPNAT inside source list, and what's our ACL number? Right? ACL number, or I'm sorry, the name is NAT. And the pool, what's the name of the pool, is HQ. Now here's the big question, right? So we've got one option left. Now they've called out here, configure static and dynamic NAT. Well, they didn't ask for NAT overload, right? And I'm looking at this here and I don't see that listed in here. So let's see if this... And actually, I'll bet we've got way more than, well, do we have more than 6 hosts? We have exactly 6 hosts. No, we don't. We have 7. So it's got to be overload. Let's see if we move the point meter here with the overload. And it did. So again, they don't call PAT out and they don't say NAT overload, right? They say dynamic NAT. Well, dynamic NAT is typically just with the pool of addresses, right? So, but it was clearly overload here, because if we take a quick peek, we've got 3 hosts here. We've got 3 hosts up here that could be using NAT, and then this 7th host up here. Well, there's only 6 usable IP addresses in this range. So we took a risk and we threw the overload keyword on there, and it worked out for us. So that was what they were looking for. So there's our NAT overload. And now we have a static. So the www.pka website, IPNAT inside source. Now remember, it's not source list here, because that would be looking for an access list name or number. It's source static. And then it wants my inside local IP. So what are we looking for? It says is registered with a public DNS system at IP address should be accessible from the outside host. So we're going to go ahead and say IPNAT inside source static, and I'm wondering if we're going to have to throw TCP on here or if we should leave it the way it is. So I'm going to leave it open for everything. So 10.0.1. And what is the IP address here? 10.0.1.2. All right. Excuse me. So IPNAT inside source static 10.0.1.2 is my inside local. What's my inside global? Well, that's the publicly routable IP, and that is going to be 209.165.200.246, and should be accessible from the outside. Outside host. So that should be it. Let's see if we move the meter. All right, so that is correct. So we've got the right NAT statement here. Let's see. Any way to connect here? Let me see if I can ping 209.165. What do we say? 200.240. Whoops. 246. Let's see if I can ping through. Not looking good right now. There could be a number of reasons for that. We haven't set up any routes yet, so we'll come back here to the outside host. We'll check that toward the end. So that is the NAT configuration, and that should be, let me double check here, and that looks Good. Okay, so on B1, we're going to set up DHCP. So let's get to global config here, and it's going to be for the VLAN 20 hosts using the following requirements. So exclude the first 10 addresses. So IP DHCP excluded addresses, and what is that range for VLAN 20? So VLAN 20 is 10.1.20.0. 10.1.20.1 to 10.1.20.10. So we're going to block off the first 10 IP addresses. All right, and now the case-sensitive IP DHCP pool, and then our name is VLAN 20. So let's see what we've got here. So we need a default router, so that's going to be 10.1.20.1. And it wants us to use the DNS server here attached to the HQ LAN. Well, here's that DNS server, 10.0.1.4. So 10.0.1.4. And include the DHCP server. Okay, we did that. So configure the sales PC to use DHCP. So we'll come down here to the sales PC. We'll go to its config, and now let's see. It's probably not going to work. You can see here we've got some issues on the links on the switch. So it's APIPA now, but that will probably change as we continue to dig in here. So now let's get into the routing and the switching configs. For EIGRP, we're going to do some static routes, and then we're going to be setting up our VLANs here. So the first thing we're going to do, configure HQ with a default route to the internet. So I'm going to say IP route, and we're going to do the quad 0, so 0.0.0.0, 0.0.0.0.0, and I missed a 0 there, so 0.0.0.0.0. And we want to use the outgoing interface, which, if I'm not mistaken, was serial 001. Let me double check. Serial 010. All right. So we're saying serial 010. So my default route on the HQ router is to the internet, and a static route to the new B LAN using the exit interface. So the new B LAN, what is our subnet up here? Let's take a look at this host. So 10.4.5.11/24, so 10.4.5.0, right, with the proper net mask. So we're going to say IP route 10.5.4.0. It's a /24. And what's my outgoing interface over to new B? Now that I've completely forgot, it's this guy, serial 001. Okay. So serial 001. All right, and let me, actually, it should not make a difference, but let's, packet tracer can be a little finicky. So let me pull that out, and let's rerun that command 001. All right, so we've got the exit interface going to, is it 10.5.4 or 10.4.5? 10.4.5. Apologize. I got that backwards, so we'll say Control A. No. I noticed the points didn't tally there, so I figured that we had a typo. 10.4.5. All right, let's see. Is it a little better? All right, there we go. So we've got our static in there to the new B LAN. We've got the exit interfaces. So now we're on to EIGRP. So configure and optimize HQ and B1 with EIGRP routing. So let's knock out HQ first since we're here. So we'll say router EIGRP 100, because that's the autonomous system number we want to use, and then we want no auto summary. So HQ should advertise the static and default route. So redistribute static, and that's going to redistribute both the static and the default route. All right. Disable EIGRP updates on the appropriate interfaces. So where do we want passive interface here? Well, we don't want it here because we're going to have an adjacency here possibly. We don't want it here because we're actually setting up EIGRP on B1. It's definitely going to be on that LAN interface. So let's say do show IP interface brief, and that's gig 00. So passive interface, gigabit Ethernet 00. And we are not advertising or running it on that internet interface, so I'm not going to put it on there. Okay, so now let's move on to router. Well, actually, we need to add in the network statements for the different networks. So we're going to say network, and we'll just throw in here 10.0.0.0 should work because we're all 10 dots, so we should be good with that. Okay, so we've got the 10 dot addresses in there, so that worked out well. Now let's drop down here to router B, right? So, or router B1, I should say. So router EIGRP 100, we know we want no auto summary, and should advertise disable the appropriate interfaces. So do show IP interface brief. So that interface is down. My guess is it should. Let's go to int gig 00 and say no shut. I want to see. Yeah, okay, so that's it. And let's double check here. So we're actually going to be doing a router on a stick, it looks like. So I'm going to leave that up, but let's do this. Yeah, so I've got a pass of those interfaces. All right, so we'll go ahead and go back into router EIGRP 100. Oops. Router EIGRP 100, and we're going to go ahead and say passive interface gigabit 00.10. Oh, and it's not. Okay, so it's going to want me to create those first before I passive them. So we're going to have to come back. So we'll come back to this passive interface setup here. But let's, for right now, let's go ahead and on router B1, let's just go ahead and get our network statement in there, and it's again all 10s, and then there you go. So our adjacency is up. So do show IP EIGRP neighbors, and there's my neighbor through the frame relay cloud, the HQ router. And do show IP EIG, or sorry, do show IP route. Let's make sure, are we picking up the default route? We certainly are, right? We're also picking up another EIGRP route that is seen as an external, which is the 10.4.5.0 network here, because again, we're redistributing the static, and we created a static route for that network. And so that's why we see that guy as a DEX, as an external EIGRP, because he's been redistributed from outside of Autonomous System 100, and he's been redistributed into Autonomous System 100. And so that's why we see him there. Okay, let me double. Okay, so we need a summary here, and this actually, they made this kind of straightforward here. Do show, I figured they would have us do some subnetting to come up with the summary address, and it's pretty straightforward. It's just a straight up 10.1.0.0/16. So let me go ahead here and say do show IP interface brief. It should be serial 000. So we're going to go to interface serial 000 and say IP summary address EIGRP 100. And what is our summary going to be? Well, they gave it to us, 10.1.0.0 255.255.0.0. So we're going to go ahead and enter here. We should have a soft reset of the adjacency. And now I can confirm that if I go back to the HQ router here. You can see we saw the same soft reset. If I say do show IP route, I should have a single EIGRP route that I do not see. So we should be learning a single EIGRP route for the 10.1.0.0. That's interesting. Oh, and it, no, it should be. Let me create the router on a stick. Maybe that is why it won't put it in the routing tables, because the route doesn't exist on the B1 router. So do show IP EIGRP topology. Yeah, so we don't have that route. So let me go ahead. Where are we at here? So VLANs and trunking, and that's where we get into the so inner VLAN routing. So now I'm going to go ahead and I'm going to set the inner VLAN routing up. I believe that's why we're not seeing the summary, but let's double check. So here we go. So we're on router B1, and we should be very familiar with the router on a stick config that we're going to need here. So interface gigabit Ethernet 0.0/0.10. Right now that interface is changed to up. Let me see if the interface being up has changed that. Are we getting that route yet? So we're not. Okay. So I'm going to go ahead and say, and remember, there's an order of operations here. If I were to say IP address 10.1.10. And actually, let me double check these. Yeah, 10.1.10, 10.1.20, 30, and 99, and we're all .1s. Okay. So if I were to say 255, 255.0, I can't do that yet, right? I've got to go ahead and declare the encapsulation, right? So encapsulation .1q, and we're going to use 10 for VLAN 10. Now I can put the IP address on here. So now let's see, with a valid route and a valid config, and that was it, sure enough. So until we actually had one of the subnets in that summary, it kept the, I was going to say withdrew. It didn't withdraw because it was never advertised, but it wouldn't advertise it initially because those routes were not in the routing table of B1. And as soon as I added the first one in, you can see our summary shows up. And that's one of the nice things about summaries, right? Is that if the other routes that are missing, if I were to add them in and take them out, the summary is not going to flap as long as I've got one of those routes that are up and in the routing table on B1, right? So it helps to isolate sort of the faults, right? Because we're actually just shooting toward this huge summary here and not really caring about whether or not B1 is withdrawing routes that are members of that summary range. All right, so back to B1 here. Let's finish up our configuration of the router on a stick. So incap.1q20, IP address 10.1.20.1. Oops. And then interface gig 00.30 and incap.1q30, and then IP address 10.1.30.1, and then interface gig 00.99 and incap.1q99 and IP address 10.1.99.1. And that should round out, and it does. So that rounds out our router on a stick configuration. Let's make sure here, inter VLAN routing, configure inter VLAN routing. Using the addressing table for the branch routers, configure and activate the LAN interfaces. VLAN 99, VLAN 99 is the native VLAN. So we want to tag that native keyword on there, right? Because it is the native VLAN. So do show run. Let's see what our gig 00 interfaces look like. So there's our .10, .20, .30, and there is our native .99 interface. So everything looks good with the router on a stick. So now we're in the home stretch here. So VLANs and trunking configuration. So we're going to configure the trunking on B1S2, which is this guy. As you can see, this guy's got some problems here. So no surprise that we're going to be working on B1S2. So I'll pull the CLI, and then sure enough, right out of the gate, we've got an issue with the native VLAN mismatch. So it says configure trunking of VLANs on B1S. Create and name the VLANs listed in the VLAN configuration and port mapping table. So let's go back up here. And actually, the first thing we're going to do here is we're going to take care of this VLAN mismatch. So the first 4 ports, it looks like FA01 through 04, are, let's go into global config, and I'm going to say interface range FA01 to 4, and these are our switch port mode trunk and switch port trunk native VLAN 99, and that should restore, and there we go, right? Restore the consistency with the native VLAN mismatch that was in place. Now that mismatch is no longer. And the reason I wanted to do that right out of the gate is because I don't want those messages scrolling up logging to the console while we're trying to do the rest of the configurations here. So, all right, now let's get in here. Let's say VLAN 10, the name is going to be admin. VLAN 20, the name is going to be sales. VLAN 30, our name is going to be production. VLAN 99, the name is going to be MGMT and native. Make sure I got that right. Yeah, MGMT and native. Okay, so let's take a look back down here toward the bottom. So create and name the VLANs, and we did. Configure the VLAN 99 interface and the default gateway. So let's knock that out. So interface VLAN 99, IP address 10.1.99. What is it going to be? 22. 99.22. And then we need our IP default. Whoops, let's get out of the. So IP default gateway 10.1.99.1. So we've added our default gateway statement in there for VLAN 99. Assigned VLANs to the appropriate access port. So we set the trunking mode. We already did this here. And then we're going to disable all unused ports and assign to the black hole VLAN. So we're going to have to scroll back up here. And let's do this. So I'm going to go ahead and say interface range. I find it easier to basically block everything and then go back into the ports. Looks like going to be 3 ports here. So interface range FA0/5 to 24 and gigabit Ethernet 0. Is it going to be 1? I think it's 0, 1 to 2. Is that right? Okay, good. So I'm going to shut them down. Shutting all of them down, and I'm going to say switch port mode access and switch port access VLAN 999. And actually, we need to create that. I just saw that. So let's exit out here. Say VLAN 999 name black hole. There we go. So now let's rerun that interface range command. So there we go. So we shut all the ports down. And then switch port mode or switch port access VLAN 999. So now I only have to go into the 3 ports that are in the table here. So we'll say interface FA06. We're going to say no shut switch port access VLAN 10, and then interface FA011. Same thing, no shut switch port access VLAN 20, and interface FA016. No shut switch port access VLAN 30, and that should do it. So let's do a do show IP interface brief. So my 4 ports are up, 6 is up, 11 is up, and 16 is up. Let's do a do show VLAN brief and see what that looks like. So no ports in the default VLAN, VLAN 1. So 6 is in VLAN 10, 11 is in VLAN 20, 16 is in VLAN 30, management and native is 99. We've got no one in there. And we've got 5, 7, 8, 9. Everybody else is shut down and in the black hole VLAN. So that looks good. Let me do a do show run on. I want to see the first 4 ports. So native. Okay, switch port mode trunk. All right, so we look good. All right, so that looks good on the VLAN side. So now let's go ahead and take a look at the port security here. So use the following to establish port security on the B1 S2 access ports. So we're going to range these out here because it's going to be the same command. So we're going to say interface range FA06, FA011, and FA016, right? So now we're going to turn switch port. We have to turn it on first, right? Switch port security. Now this is interesting. They say allow one MAC address to be learned on the port. Well, that's the default. So I don't actually have to type in switch port, port security, maximum 1. We'll type it in anyway. I don't think it's the points aren't gonna move, right? Because that's the default. So it stayed at 81. So now we're gonna configure the first learned MAC address to stick to the configuration. So I'm gonna say switch port, port security, MAC address, sticky. And they certainly gave you some good clues there by putting the word stick in there. And then set the port to shut down if there's a violation. That again, switch port, port security, violation, that is the default. So even if I put shutdown and hit enter, we shouldn't get any points for this because that's the default. In fact, if I say do show run, and we take a look at port 6, you can see, does it say switch port, port security, violation, shutdown, and switch port, port security, maximum 1? It doesn't, because again, those are our defaults. So that is the port security setup. All right, so now we are down to, let me check here. So let's see if sales is able to get a DHCP address. So flip it to static, and bring it back to DHCP. Can he pick up a DHCP address yet? He cannot. So he's still getting an APIPA address. Let me double check on that. Let's say do show run. And he's port 11, so there it is. And it doesn't appear that the MAC address is being picked up here. So let me save my config. All right, so let's come down. We'll wrap up here with the access list policy. So it says because HQ is connected to the internet, we're going to configure a named ACL, and this is obviously going to be an extended ACL, called HQ inbound, and it wants the ACEs, the access control entries, to actually be entered in a certain order. So let's jump onto the HQ router here, and I'm going to type end. We'll go to global config. So I'm going to say IP access list extended, and what is the name of our access list going to be? It's going to be HQ inbound. Spell that right, HQINBOUND. All right, so we're going to permit. So what are we permitting? So it says inbound HTTP requests. So we're going to go with permit TCP any, right? Because we're allowing anybody to come in, but who are we allowing the HTTP request to go to? So we're going to say they're going to go to 209 because this is our inside global address. So 209.165, it was 200.246. All right, and now what kind of requests? Well, HTTP, so we're going to say equal www. So permit TCP from anyone to host 209.165.200.246. Remember, this is going to be applied in the inbound direction, so it's going to be on the interface facing the internet. So that's why we're going to allow it, because again, sort of the order of operations is, even though we're using NAT, right, when the packet comes back in or initiated from the internet into the HQ router, it's actually going to look at the ACL first, see this 209.165, and then it's going to process the NAT to flip it to the inside local IP address. So that's good for that one. The next one is allow only established TCP so permit, and this is kind of straightforward. So it's basically going to be permit and TCP. Is it TCP? Let me double check this. Yeah, TCP any and established, right? So from anywhere to anywhere internal in the network, as long as it's established. All right, now we're going to allow only inbound ping replies. So echo replies are going to be allowed in. So that's going to be permit ICMP any, and then let's go back and take a look here. We got wide range with ICMP, and so we're going to allow echo replies, right? And then it says explicitly block all other traffic. Well, that's deny IP any. And so we'll go ahead and hit enter, and that should take care of that access list. So we've got the access list. Well, now what we need to do, excuse me, now what we need to do is apply to that outside interface. So I'm going to say interface serial 010 and IP access group, and what's the name of our access list? It's HQ inbound, and what direction? In, right? So coming into this interface, which means before it hits the routing engine and gets processed and sent out, right? So inbound. And let's see if we've got the right direction here. And we didn't move the point meter, but that should be correct. Did I get the right interface? Serial 0 interface. Serial 010 on the HQ router. And I'm just looking at that to make sure. Yeah, that should be right. So one thing I just realized as I'm looking, let's see, do show run. So we set the NAT up, but we never declared our IP NAT inside, IP NAT outside here on router 1. So let me double check here, make sure we've got. Right. There it is, IP access group HQ inbound in. Okay, so it's there. That should be correct unless there's something wrong with my ACL. So let's do this. Let me go ahead and get these IP NAT inside and outside statements. So let's go to interface gig 00 IP NAT inside, and that did move the meter. Do show IP interface brief. Serial interfaces drive me crazy here. So interface serial 001 IP NAT inside, and then interface serial 000.41, right, our sub interface IP NAT inside. And so that takes care of 1, 2, 3. Now we need the IP NAT outside, so interface serial 010 IP NAT outside, because that's my outside facing interface. Alright, so we've got those statements on there, we've got the access list done, and was there something that we overlooked? Alright, so we're 10 points short. Let's do a quick check results here, because that is a ton of stuff so far. That's right, my passive interfaces. So the IP address on .30 is wrong, and the pool address is wrong. All right, let's take a look at that. We'll look at these in turn here. So let me take a look at my DHCP pool. That explains why we're not getting the DHCP address. Probably typoed something there in the pool range. So on B1, do show run. What is my range? Oh, that certainly is the problem. Does anybody see what the problem is here? It's saying that there's a problem with the range, and the problem is that DHCP pool VLAN 20. The problem is that I don't have a range defined. 10.1.20.0. It's a /24. So now I have my DHCP range in there on B1. So when I come over here to sales now, bingo. Now we're getting our DHCP address. All right, so that's good. Passive interfaces. That was a concern here on B1 because prior to configuring everything, it wouldn't allow us to passive those interfaces. So passive interface gig 00.10.20.30 and .99. right? So those should be all of the interfaces we need to have passive for the router on a stick config. There we go with our network statement, the auto summary, and I can't remember what we said. Oh, that's right, the .30. Let me scroll down here and make sure. So my NAT ACL, it doesn't like that. I've got my passive interface on the HQ router. All right, so let's take a look here. Let's knock out this IP address. Let's make sure that I didn't typo my IP on do show run. And that is certainly incorrect. So we're going to say interface gigabit Ethernet 00.30 and IP address 10.1.30.1. Alright, so we've got that taken care of, and I need to do my passive interfaces here on the serial links. Make sure I get the right serial links. So we're going to passive 000, and we're going to passive, hold on a second here. Yeah. Passive 000. I'm sorry, I'm looking at the wrong router. Sorry about that. I was wondering, I'm like, we're missing some interfaces here. Alright, so let's do a do show run. And everything just kind of froze there for a second. Alright, so do show run. So here we go. So the only interface to passive here, and we did the gig 00, is going to be, I wonder if it's looking for the link to the internet to be passive. Serial 001, or I'm sorry, 010. And then the gig 00. Those are the only ones that should be. Alright, so router EIGRP 100, passive interface serial 010. Was that what it was looking for? It was. Let me make sure, because we've got it. Oh, we have maybe the adjacency. There is no adjacency because we're redistributing that route, so it's going to want, yeah, the interface that goes out to the other guy. And then we're left over with the NAT statement. So let's drop this over here. Let's do to new B, and then we'll say passive interface serial 001. All right, well that should take us to 98 out of 99, and it does. So we've obviously got something is up with NAT. So let's take a look here on the HQ router and see what we've got going on with our NAT configuration, because it doesn't like the way we've set up the NAT. Okay, so IP NAT pool HQ 209.165.200.241. Let me scroll down here. So this is the section that we're concerned with right now, because something's not right in this section. 241 to 209.165, 200, 245. The net mask, that's a correct net mask. So we've got IP NAT inside source list NAT pool HQ overload, and I remember that actually granted us the point for that. And then IP NAT inside source static 10.0.1.2 209.165 200.246. So that looks correct. Let me check the IP access list. Standard NAT. Oh my goodness. Okay. Does anybody see what the issue is? I just saw the issue. So when I created this initially, I created this as the 10.0.0.0 and then wildcard masked it, thinking net mask, and put it as a /24. 4 when in fact we're supposed to be allowing, it's a /8. So I've got my wildcard mask is wrong there. So here's what we're going to do. We're going to come out, I'm going to say no IP access list standard NAT, and we're going to say IP access list standard NAT permit. And the easiest statement of all here I managed to get wrong. And there's the wildcard mask. So that's the wildcard mask we're looking for, and sure enough, that takes us to 99 out of 99. So let's check. So from outside host, I should be able to get to www. Let's try it in a web browser here. So it was 209, 165, 200, 246. All right, so there's the public website. So I'm able to go from this outside host over to the www.pka server. What about from sales? Can I get to www.cisco.pka? And remember, I'm using a DNS server, so this should work. www.cisco.pka. There you go. Welcome to a simulation of the Cisco homepage. All right. Well, it has certainly been an exciting semester, and this is a fantastic activity that literally touches on almost every single aspect of the technology and the configuration work that we've had to do throughout the semester. So this wraps up CSI 258, and this is it. So you guys are now on to take your CCNA and to pass it. And hopefully this has answered any questions that you had about this activity. I will see you guys on Saturday for the final. Have a great evening.